So this is a brief overview of my code for ME3901's Module 4 Part A report to demonstrate that I incorporated smoothing as well as the linear regression equation for actually calibrating the sensor output of the thermocouple. So besides the basic setup, like actually creating the ADC object and setting the input that we're reading the voltage from, we have some of the smoothing variables here. So we have max readings, which is currently set to 10 and essentially represents how many data points we are taking the average of. And then we create the actual array itself, currently called readings in the code. And then a few variables that are currently set to 0 for current reading, the total of the voltages, and then the average of the voltages, which we'll use later on in the loop. So within the while loop, we essentially read the voltage from the ADC and then add it to the running total of the voltages, and then advance the index on to the next one. So in this case, we're just adding 1 to the total. And then we have some lines here checking whether the current reading is greater than or equal to the max readings, in this case 10. And if it is, it just resets the current reading back to 0, so it continue to count up. And then once we have those 10 values in the array, we then take the average of those values and then save it to this average variable. And this is actually what is being output in this print statement for the voltage. But before we output the temperature, we then use the calibration curve. I will show you the data and the graph that I used to acquire this later on. But this is the equation here, where we have the temperature, the raw temperature set as the input, and the output being the actual, or the variable that we're saving this to, be the calibrated temperature. And then it is the calibrated temperature that we then take and output here right underneath. So we have the raw temperature and then the calibrated temperature being printed at the same time, just so I can view the difference, and then just a brief time delay.